Great, everyone. Thank you for coming to our meetup. We're on to our next speaker now. And the topic of the talk is on ninny-json, type classes that know that none is not null, by Nathan Fischer. Nathan Fischer is a San Francisco-based developer using Scala to increase productivity and push errors to compile time. Over to you, Nathan. Thank you for doing this talk.
All right, thanks, Salar. So yeah, like Salar mentioned, I'm a Scala developer in San Francisco. The team lead at Lightform. We make projection mapping software, like this glittery thing in the background you might be able to see. Giving a shout out to the company because they gave me some time to work on this during work, and they're also really good about open sourcing some of the Scala stuff we built internally and giving me some time to work on some open source projects in the Scala community like Mill and stuff like that. So this talk is about, as we mentioned, that none is not null. And what that really means is in JSON libraries, most of the ones in Scala today don't make a distinction between a null JSON value and a field which isn't present. And so we're going to talk about kind of why that matters and what we might do different. So ninny-json is a library that I wrote which has some new typed classes that aims to address this issue, making a distinction between what none and null are, or absent fields and JSON null. And so we'll talk about why we care, what the difference is, what the libraries do today, just a survey of kind of the three most popular, or three of the most popular JSON libraries in Scala, some new proposed type classes in Ninny, go over some questions, and if there aren't too many, then we'll jump into some usage examples of what using the Ninny library actually looks like. So what is a type class? I know there's some people from the Java meetup and maybe some new people to Scala. So we've got this kind of scary looking Wikipedia blurb, and it talks about ad hoc polymorphism. And we're like, that's kind of a big term, but really all that means is that it's allowing us to define abstract behavior outside of a type hierarchy. So in kind of more simple terms, usually we think of abstract behavior coming from a supertype. So we say, this thing is a subtype of that thing, therefore it has this behavior. Type classes let us say, I don't know where this thing came from, but I know that I can define this behavior for it. So an example of that would be if we have some associative behavior. We can combine two things of type A into another thing of type A. And for integer, we can implement that for addition. So just add two integers together, easy. And so that would be a type class. And one of the big things in type classes is composition. So if we have another type class, sum, where we've got a bunch of instances of sum A, we want to be able to combine all of them together, not just two. And so we can say things like, okay, well, as long as we have an associative for A, then we can build a sum for A. And we can just, reduce it down. And now we've got a sum for our list of anything, not just of integers, but of anything. And so that composition and that ad hoc polymorphism are two of the big attributes of type classes. And we'll see this carry over into JSON as well in terms of building serializers and deserializers to and from JSON for complex types. So for the Java people, do we have type classes in Java? We definitely do. You might have seen comparator. It compares two things of type T and tells you which one's bigger or if they're equal. You don't see type classes in Java as often because the implicits that Scala has and the higher kind of types make type classes a lot more useful. And so the reward of using them in Scala is a good bit, or the implicits make the difficulty of using them lower, and the higher kind of types make the reward of using them higher. So they're definitely more popular in the Scala functional world. So who cares? Null, absent field, what's really the difference? In Scala, we like to say that null is none anyway. So one reason, and maybe the most minor one, but is testability. So if we've got some class and it's got an optional member, and we turn that into JSON, we might want to make an assertion that says, hey, once I turn this thing into JSON, it shouldn't contain its optional member if that optional member was none, right? So we want to say, yeah, the value should not be in that field. Or another way we might write it is that, hey, if I try to pull that value field out of that JSON, I should get none. But with the libraries today, that's not actually what happens. So these assertions look correct, but if we run them, they're not actually going to be. So our output JSON actually might contain a field called value, and we might not get none, we might get null. And so instead we need to write a test like this that says, hey, if we try to pull it out, does it contain JSON null, which covers both the case of it's not there or it's null. And that's not the end of the world, but that's definitely not the first assertion we would write when we're just going through our tests. And so that's kind of a sign that things are a little weird. So another case where we care about the difference is in JSON RPC. I don't know if anybody's worked with it, but it's a language independent, transport independent RPC standard, and it uses JSON as the serialization format. And in JSON RPC, you've got requests and responses. And in the responses, you either have a field for the result or a field for an error. And the client will look at those two and say, okay, you know, what happened with my request? And the spec specifically says that you can't have both of these fields in the object. It's got to be one or the other, full stop. And so if we use a lot of the Scala libraries today and we serialize something that maybe has an optional error and an optional result as a case class, this is the JSON we're going to get. But this is the code that a lot of clients are going to write, which says, hey, does that JSON contain error? Because the spec told me that if it does, then it was definitely an error, and I shouldn't expect that there could be both of these guys, or that error could be null. And so that would be a correct implementation of the client, but it would break. It would try and parse the error, and it wasn't an error, it was actually a success, and our error was just a null placeholder. So the last example is an RFC called JSON merge patch, which is pretty cool, and it lets you kind of partially update resources. And it says if you've got some resource, some existing resource, and some JSON object, you can take all the fields that are in the JSON object and update the corresponding field on your resource. And if the field isn't in the JSON object, you just don't update it. And if the field is null in the JSON object, then you try to null it out or delete it or whatever that means for your resource. So there's kind of an obvious issue there where if all of the fields are always present and they just happen to be null if you weren't putting something in there, then you're going to end up deleting, you know, the majority of your resource when you try to go update it. So this is the case that we'll use as an example when we go through, look at our different JSON libraries. We'll try to implement an algebraic data type for merge patch and see if or how we're able to do that in our different libraries. So do we want to write another library, another JSON library for Scala? We've kind of got a million of them already. So let's dig into like, what are the most popular ones we've got, and will they work for those use cases that we talked about already? So play JSON is a big one. We use it a lot at Lightform currently. It's got some pretty straightforward type classes. We've got a writes that writes a value into JSON, and a reads that reads some JSON into a Scala type of some kind. And that's a JS result, so that basically says it could fail. But in this, there's not really a way to say, hey, there should not be an output here. So writes, when it's implemented for option in play JSON, just writes null, and null, or JS null is, you know, a subtype of JS value. And there is no reads for option of anything because there's no way to know from this type signature if the field was absent, only if it was null. So that's a bit strange. PlayJSON has some macros which are handy, so we don't need to implement those type classes by hand for each of our types. So we have my class. We can just make a reads for my class by just saying json.reads my class, nice and easy. And it uses implicitly a reads for string because that's the type of the my field member. But we see something kind of strange if we have an option member, because we said we need an implicit reads for our field, and we said in our last slide that there is no reads for option. So how does that work? How are we able to resolve that? It's because option gets some special treatment in PlayJSON on the read side. And this macro basically generates this code. And validate opt is a special method for option that is able to use the normal type class for string and decide whether it should use that or return none based on the context of looking up a specific field in that. So that works fine when we're working with option in like our normal cases. But if we go and try to implement kind of a algebraic data type for patch, where we talk about wanting to update the field, clear it or ignore it based on if the field is absent or null, we can't implement a type for patch, and there's no support for patch in PlayJSON's macros. So what that means is that we have to do the same workaround as what the macro does, and basically implement our own reads and writes for the data type for every single data type that contains a patch member. And so that's kind of a drag. And we can basically see that if we want to ignore the field, there's no input value that we could find that would lead us to figure out that that's what we need to do. And on the writing side, if we have an ignore, there's nothing we can return that's going to tell it that that field should be absent. So in summary, PlayJSON is a little weird because there's a type class for option on the writing side, but not on the reading side. And we can't use macros if we care about if the field is present. So that's going to lead to a lot of boilerplate. Circe is another really popular library for Scala, or for JSON in Scala. It doesn't use an AST for its JSON, or it doesn't expose it at least. It just gives you this top level JSON value type. It uses these things called cursors. And you can think of the cursors as something that sort of looks at a specific part of a larger JSON object. And the A cursor is kind of like a try in Scala. So it can either be a success or a failure. And depending on which, you can kind of infer different stuff. So its type classes, the encoder looks pretty much just the same as it did in play, and it has just the same drawbacks. It, writes none as null, and yeah. The decoder, though, is interesting because it takes a cursor rather than a JSON value as its input, and so that cursor potentially can be a success cursor or a failed cursor. And there's some subclasses or overridable methods in that decoder type class that let us take the A cursor rather than the success cursor. And from that, we can infer that the field was absent. So that means we can implement a decoder for patch, even if we can't implement an encoder. So Circe, in summary, we can't implement that encoder. We can implement the decoder. And it also has macros, just like play. But again, if on the decoder side, you want to, or on the encoder side, sorry, you want to do something, you need to go and implement that whole parent class by hand. So the third one is JSON for S. And JSON for S is a project that aims to have one uniform algebraic syntax tree for JSON and Scala that different libraries can then use. but it's also got type classes for reading and writing. And these look just like the ones in play, with the difference that these throw exceptions rather than return success or failure as data. And the interesting thing in AST is that they've injected this J nothing in, and there's no concept of nothing in the greater JSON spec, but in JSON for S, they've kind of put this guy in here, and it lets us implement patch the way we want to. And so now we can use J nothing in those places where we didn't know what we were going to do with play JSON. So that's great. So we actually have a way forward now with JSON for S. But there's still a little bit of drawback. So if we have some object, some JSON object that we've built by hand that has a J nothing field, we get something common, kind of reminiscent of our weirdness in our tests, where we say, hey, does this object contain a specific field? And that returns true. And if we go to look up that specific field, we find, oh, there's nothing there. And so that's kind of a weird inconsistency. And we could just write, oh, let me look up the field and check that it equals nothing. But ideally, our first attempt wouldn't compile at all. So that's something we like in Scala, is that if we do it wrong, hopefully it doesn't compile. And the compiler tells us about our error. So yeah. Hopefully we can do a little bit better than this AST, even though it does give us what we need to implement our patch. Maybe we can do it. Maybe we can do it better. And how do we do it better? So what we want to do is move that concept of nothing from the AST, where JSON for S has it, and move it into the type classes. So in Ninny, the AST for JSON is very vanilla. It's just got all the normal types you find in the JSON standard. But if you might have guessed from the title, we've got options when we're going to JSON and options when we're coming from JSON. And if we look at what that looks like when we go to implement patch, it looks a lot like it did in JSON for S, except that now we're able to say, oh, okay, we can say it's just not there. So we can just say ignore is just none, like don't output that JSON field at all. And it won't be present in the AST either. So if you're eagle-eyed, you might have noticed that the patch to JSON has a type class that I didn't mention, to some JSON. And basically, sometimes we want to guarantee that our thing is going to output JSON and not just nothing, right? Because we can't return none to our API consumer or something like that. We need some concrete JSON to give them. So to some JSON lets us do that, and it also lets us bypass the awkwardness of always having to deal with options. And as a bonus, it means that our patch to JSON only works for an A that definitely outputs JSON. And so we prevent the issue where you might try to serialize and deserialize and end up with something not symmetric if you tried to write an A that was not going to output JSON, that would get interpreted as ignore rather than update to none. And you can't get that with J nothing. So like I said, it's kind of a drag to always deal with option. And to some JSON, kind of the implementation is here, lets us bypass that. And from JSON, that's not really an issue. We can just add an extra method to the existing type class. So sometimes we said, okay, we definitely want some JSON, but what if we definitely want some JSON object and not just any old JSON? What if we want both? How are we going to do that with the type classes we showed? Well, we can't, and I lied. Those aren't actually the real type class signatures. There's a couple different, and basically the type of the JSON value is something that we have as a generic here, and we have type aliases for these different specific cases. And this actually works pretty well. So the implementations for patch that I showed before, those don't actually change in light of these new types that we have. They work just fine with the type aliases. So largely, when you're using the library, this is kind of behind the scenes. You don't need to know that there's a toJSON value. You can just use toJSON of A directly. So we found lots of different problems with other libraries, and we went over some solutions. How do we do in shoring up those problems? So trying to get a patch from JSON was a problem for Play. Trying to get a patch to JSON was a problem for circe and Play. The AST was kind of weird in JSON for S. And having null floating around was a problem in all the libraries as the default way that you write none. So we managed to fix all of those. And we also actually have macros thanks to shapeless. So we don't need to write any of that boilerplate overhead that otherwise would have brought us onto the same level with Play. And that will wrap us up to any questions. And if there's no questions or we have extra time after questions, we can go through some usage and code examples of using Ninny.
Awesome. Any questions, everyone? I'm keeping an eye on Twitch. One question for you that I've got. Have you considered using something like Magnolia instead of shapeless? I haven't used either of them, but I've heard from others that on benchmarks Magnolia is faster.
I have not. I have not checked it out, but I definitely would be curious to. There is a GitHub project and a PR showing what the Magnolia implementation would look like. Would be awesome.
Cool.
Hey, Nathan, question from the chat. Was curious if it was supported in all Scala versions?
Yeah, so on GitHub, there's a issue open marked as a help wanted. Currently, this is implemented for 2.13, and it should be pretty easy to get it cross-building to 2.12. I'm not so sure if it'll be as easy on 2.11, but I definitely also want to implement Scala 3 support once that is finalized. So 2.13 at the moment.
I think the person said they were using Play Framework, FYI.
Framework or Play JSON?
Play JSON was because I asked the chat question of what's everyone using, and he replied that it is using the Play, assuming that it meant Play.
Oh,
JSON.
that was from earlier. Okay, sorry.
Yeah. There should be a pretty easy drop-in replacement for Play JSON for most use cases, actually. You can just do a simple control, replace, and just swap out the macros and the imports.
Someone's asking now, is there any other external dependency for ninny-json?
Good question. I believe it is just, no, it's not just shapeless. I take it back. It is shapeless and, actually this is at the end. Shapeless and John. So John is a JSON parser, so we offload all the JSON parsing to John, where it's a really fast, robust parser, and we don't have to worry about messing that up ourselves. I thought about bringing in cats, but didn't do it.
Great. I don't see any. Oh, here we go. Is there a way to allow and forbid which fields the client can update in a JSON patch?
Definitely. I usually implement it by having a data transfer object that is a case class that has all the fields that are allowed to be updated, and then has that, something like that patch data type as the value. And so then you take that data transfer object and apply it to your resource. And so only the fields that you put in there are going to be updatable on the other end.
Great. Any more questions? If not, we look forward to your examples that you mentioned. you've been thanked on the chat.
Oh, awesome.
Yeah. Appreciate you coming and presenting and taking the time to prepare all this. Yeah, look forward to hearing more from you if you want to come back. We like I said, definitely want some more Scala on the SF Jug. So you're certainly welcome to present at any time, both of you. So yeah, thanks, Nathan. Appreciate it.
Yeah, I'll maybe do some more educational beginner Scala stuff.
Did you have any more to show today, Nathan, or is that the end of your presentation? Because I thought you mentioned there was something you wanted to demonstrate.
Yeah, just some quick showing what that code actually looks like in use.
Cool.
So
Yeah, that's awesome.
you've got some really straightforward. You've got some variable or value. You can just say to JSON, and it will give you that JSON value, or to some JSON if you definitely know you want it. You can take any JSON and convert it into your Scala class with just plain to, and that works both on an option and the actual JSON. To and from JSON.auto invokes that macro, and it just builds the type classes for you. There's some cool dynamic syntax where if you parse out your JSON, you can invoke, a method like .hello directly on the JSON value, and that'll, if there's a field called hello, it'll return, the JSON node at that field. There's also a non-dynamic syntax in case you need to pass it a string, but I think dynamics are one of the more fun and underutilized Scala features that people don't realize you can safely, have funky syntax like that. There's definitely some PlayJSON inspired construction, so it's a lot similar to building a map in Scala or building a sequence. And if you do want to write out marshallers or unmarshallers by hand, they return a try, and so you can just build them out in a for comprehension that's pretty tidy. You could also write your own automation to just generate this if you're had some other external tooling like an open API specification or something like that would be easy to generate this kind of thing from. So yeah, ultimately, I hope that other Scala libraries adopt this capability in their type classes, and that we can sort of, lay ninny-json to rest. But that may be quite a while off. So in the meantime, aiming to get it production ready. I mentioned it uses John. It's got quite a bit of test coverage, and I'm going to be building out some integrations with other tools in the Scala ecosystem. Akka HTTP will probably be first, and I'm contemplating adding support for binary JSON. We do a lot of Internet of Things style MQTT communication in Lightform, so some binary support there will be something we might build in-house and open out. And it's definitely open to feedback or contributions on GitHub. Encouraged, you might even say. And that is all I have.
Great. Thank you, Nathan. Any new questions from anyone? Thank you so much. Seriously, it was a wonderful talk. I'm glad to see more options for JSON parsing in Scala. Nothing in chat. Anyone on Zoom got any questions for Nathan?
I think we can call it a wrap.